Taeyeon is affiliated with Blue Marble Space Institute of Science that I am affiliated to. Hello, we never met yet, I think. And he will be talking about a new biomarker detection method for autonomous activities in a volcanic cave, preparing for a robotic astrobiology mission to the cave on Mars. And that's connected with the Brio mission, I guess?
Yes, right. Yeah.
Okay. So the space is yours. You have 15 minutes. I'm going to let you know after 10 and then 5 minutes discussion. Thanks.
Okay. Thank you very much.
Are you at Ames right now?
No, actually, yeah. I mean, I'm living in South Korea, and I'm just a robotics engineer. Yeah. Can you see my screen now?
Yes. Yes, I do.
Yeah. Yes. Okay. Hello, my name is Taeyeon Kim, and I am BMC visiting scholar, and I am researching about the computer vision and robotics algorithm. And I'm happy to be able to talk at this Life and Space 2022 conference. What I will talk about today is deep learning-based biomarker detection method that can be used for solving the bottlenecks of the remote robot autonomy algorithm. This is application research using real-time semantic segmentation network, which was developed for other purpose. But yeah, first, let me introduce you to why we started this study. There are many reasons why it is difficult to find life on other planets. Maybe wide range oscillation of temperature and micrometeorites would be dangerous for life. But cosmic radiation can make life extremely difficult to live on the surface on the other planet. So yeah. So however, recent studies have shown evidence that lava tubes can exist on the moon or Mars, and these lava tubes can be candidates for habitats that can protect humans from these hazards. This is a pit hole found on the moon that has a different shape than other craters with vertical walls. Because the satellite range of the observation is limited, and it has not been directly observed what may be inside, but scientists estimate that there is a possibility of the lava tube inside the moon and Mars. And if this crater is a pit crater, it could be an entrance of the lava tube. And then pit crater is a geological structure formed when a lava tube is formed, and then the surface collapsed. Yeah. So yeah. And the pit hole of the lava tube on the Earth are already showing a similar shape with the moon or Mars. So this is and this on the right side of the image, you can see this is the surface of the moon, and then some scientists guess this is the lava tube pit holes, and this consecutive moon pit holes support the possibility of the existence of the lava tube. And then not only the moon, but also already there is a possibility the existence of the lava tubes on the Mars. So maybe if the human is going to the Mars, then the Mars lava tube would be the candidate for the human shelter. So yes, I'm contributing the Braille project now, and then we are researching about the autonomy robots concept of operation, and then that can be explored the subterranean environment, and we consist with the NASA JPL, Ames, and BMC's engineers. So this project objectives are to characterize the microbial life and its life signature within the volcanic cave, and demonstrate the subsurface activities using robots in a Mars mission scenario. So that so this is the concept of operation of our project, and we are using the nebular autonomy system, which was developed by the JPL, and then actually this is developed for the DARPA subterranean challenge, and then that challenge is to detect the survivors or the human artifact in the GPS denied area. So this autonomy software stack can explore the GPS denied area autonomously and transfer the data to the base station. And then our Brave project using the four-legged robot Spot, which is made by the Boston Dynamics, and then we made a map of the cave and then searched the bio evidence using this robot. So this robot is consists with the vanguard and rearguard. So the vanguard is going deeply the cave very fast, and then it make a subterranean map. And then the rearguard robot having the scientific analysis instrument and then high resolution camera. So so after the vanguard make a very precise map, and then if this robot pick the scientifically interested area, then rearguard is going that rearguard is go to that area and then analyze that war area detailedly. So our ultimate goal is that maximize the coverage of the scientifically interested area. So however, for the remote subterranean environment exploration robot, there are many limitations. First one is that this is the perceptually degraded environment, so it is really bad for the camera or other sensors. It is really bad to detect other to get the informative, good quality images. And the second one is that because of the limited robot operating time due to the battery, so we need to set a very effective and efficient path planning method. And then third one is the narrow communication bandwidth, because unlike the surface, this is a subterranean environment, so we should use a communication node hop. And then because this is usually the data bandwidth is really low because of the multipath of the wireless signal. So we should reduce the data size lower than the limit of the communication bandwidth. And the last one is the low human cognitive load is another bottleneck, because if the vanguard can get the informative result and the map, and then when it transmits this data to the base station, then the human scientists evaluate that information. However, if that data is too heavy, and then scientists cannot give the correct response within the robot operation time, then the rearguard the efficiency of the rearguard robot will be lower than the previous the objective. So we should solve those four limitations. So that's why we are making the biomarker detection algorithm using the deep learning based method. So already those algorithms used for the Mars Explorer or the autonomous cars for the path planning algorithm. But previous researches are focusing on the risk area, find the risk area. However, we can use this information to make a reward map. So the reward map is maybe we can say this is the resource map, or we are saying the scientifically interested area. So it can be used for the maximize the scientifically interested area coverage. So this is the polyps and yellow biofilm. We can find this feature on the terrestrial lava tubes, and then there are many biomarkers in the lava tubes, but we select those two features for our initial development, the polyps and the yellow biofilm. So,
you
however,
have 5 minutes.
Sorry, yeah. So before it is, even it is the verifying the concept of operation, we should select the good sensor. And then the challenges is the first one is we need to reduce the motion blur, and the second one is we need to increase the signal noise ratio. So to do that, we need to select a big size sensor to reduce the exposure time. And then to select a good ISP, the image signal processor, we can we can get the high throughput and fast autofocusing speed, and then we can get the good noise reduction algorithm. So on this table, maybe you can see this slide later, but on here we investigate 4 cameras, and then the size sensor size is 1 inch, and the other one is smaller than the 1 inch. And on here, the left image is best, and going the right one is this is bad, and this is proportional to the sensor size. So simply the good ISP and the big sensor size is important to get the good quality image. So for the preparation for network training, we collect the data set on using the robot's camera and the handheld camera. So this is the example of the yellow biofilm. And then second one, we need to make annotation. And then this is we call the labeling, and then this information used by the machine learning algorithm. And then this is the ground truth. And the machine learning algorithm train this information and then output the polyps and yellow biofilm area. And then last one is that because we having very small amount of the data set, so we need to augment the data set. So by the increasing the brightness or decreasing the brightness, and then make adding the blur or the noise or doing the flipping, we can increase the total data set size. So and then we select the STDC network, which is a semantic segmentation network, and then which is a SOTA on the last year. The reason why we select this network is that because we need to send the exact target location to the scientist, so that we need a polygon result, not a bound box result like autonomous car. And then second one is that we need to learn this algorithm on the mobile robot in real time. And then for the mobile robot, usually the mobile robot doesn't have the powerful computer, so we select very lightweight deep learning algorithm. And then this is the STDC network, the architecture. And then shortly, this is a semantic segmentation network module to extract the deep features with the scalable receptive field and multi-scale information. And then actually, this is to explain those architecture is a little hard. So if you have a question, then I will answer it during the questions time. And then, so this is the result of our initial biomarker detector result. And then we use the STDC net 1446, and the inference speed of this network is that 8.11 frames per second at the small size computer, which is a Jetson JBR AGX. And then the MIOU, which is when we evaluate the performance of the semantic network, we use a MIOU, which is a mean intersection over union. And this MIOU 50 represents the ratio when it is detect the object area correctly, more than 50% on each cluster. And the left yellow area is a yellow biofilm area, and the area where the detector estimates to be a biomarker is overlaid with a yellow color parameter, and the right is a green area is a polyp. So this is an image frame then, collected using the PTZ camera, which is attached on the four-legged robot spot. As you can see on here, this algorithm does not perfectly cover our biomarker area, but this information is used for selecting the image frame. Image frame and the scientifically interested area. So the entire transmitted image stream can be reduced. After that, the scientist can see this parameter result, and it will have to recognize their analysis of this image. So this is a video result, but I will skip it. This is the same result, and then we can also see that it can detect biomarker even in blurry image. Of course, if the focus is blurry, it cannot detect on the polyps. So we need to improve these algorithms by adding more data set. So we need more data sets for various scales and need to do the generalization. And the developed algorithm can be used to solve the various bottlenecks in the robotics autonomy stack. And then, so you can see on here, there is a processor limit and the wireless network limit and the human cognitive limit. However, by we select a good, by we making the good object detection algorithm, then we can increase the true positive object ratio so that we can reduce the total data size that can be fit within the wireless network band limit. And then by that one, we can simultaneously solve the cognitive limit problem. So and then by this information, the human can interacting with the robot easily, and then so we can maximize the coverage of the scientifically interested area by the these robots within the limited time. So just summarizing this, we solve the remote robot bottlenecks by semantic segmentation network to detect that can detect the biomarker area, which is for selecting the scientifically interested area. And then, so next step is we need to fix our bug and increase the robustness and apply the hardware accelerator to increase the inference throughput. And then we need to add more training data set for generalization. However, ultimately we need to develop a new classification algorithm to make a resource map, because we cannot guarantee like this bio feature will be exist on the other plans. So we need to make more general algorithms to switch this one. So I hope that the result I have introduced today will be useful to you. And thank you very much. Maybe that's it for my presentation. Thank you. I cannot hear you, but can you hear my voice?
Voice. 1, 2, 3. 1, 2, 3.
Yes.
Okay, cool. So yes, thank you so much. There was an information-dense presentation. Thank you so much, a lot of it. You have a question on the chat, so maybe you will be able to answer it by writing, because we have to run to the stage where we will continue with the discussion on AI use in Search for Life. I just want to make you aware, if you haven't heard, there was a presentation on this conference by InSpace team from Poland. Alexandra Klasa was presenting. They just won a second prize on a competition how to design a robotic mission based on dogs like that, like the Boston Dynamics in lava tubes on Mars. So it's an obvious collaboration there. Okay. If you need any more details, reach out to me. I'll put you in touch, and please use some time to answer the questions on the chat before going to stage.